Welcome everyone to the second CEPR-VDEV seminar series for the fall, where we're going to have the honor to listen to Ted Miguel from Berkeley University speak about deworming 20 years later. My name is Martina Björkman Nyqvist, and I'm co-organizing this event with Karen McCord, Gianmarco Leon, Giacomo Di Giorgi, and Eliana La Ferrara. Before we get going with the seminar, I would just like to tell you a little bit about the seminar if you haven't been part of this before. So this was started in the spring as the Virtual Development Economics Seminar Series. And now, since the fall, we're joining forces with CEPR, and we're very thankful for all the help that CEPR and Mandy gives us with organizing this event. Thanks, Mandy, for that. And now some logistics before we get running. The seminar is 75 minutes. Ted is going to present for 60 minutes. And then after that, we have the opportunity to ask Ted questions about the paper. So if you have any clarifying questions during the talk, please write them in the Q&A chat. And then for the clarifying questions, we will ask them at some intervals, some few stops in the talk. Then after 1 hour, we will have the Q&A session of the seminar where you actually get to ask the questions yourself to Ted. And you do so by raising your hand, and we will then unmute you and you can ask the question yourself. Seminars are recorded and they're available on the CEPR YouTube channel pretty much after this seminar, and you can watch it again or ask friends who are on different time zones or don't have the opportunity right now to present. Okay, Ted, we're ready, and we're very happy to have you here as the second speaker in the fall seminar series. And thank you for waking up early and taking time to present in this event.
Thanks so much. It's great to be here. It's such an awesome idea to bring people together really globally for this seminar. So really, I'm delighted to have the opportunity to present. I'm also really happy that my co-author, Michael Walker, is here as well. And he'll also be able to respond to some of the chat and answer some questions. And several other colleagues are also online. So as Martina said, I'll be presenting the 20-year economic impacts of deworming. This is a new paper we just wrote up. Can you guys hear me okay? Yeah. The co-authors are Joan Hammery, Michael Walker, Michael Kramer, and Sarah Baird. And the author order there is randomized using the AEA randomization tool. So the question that really motivates us in this talk is the link between child health and later adult living standards, the possibility that investing in child health and nutrition can have an effect on living standards is something that motivates many policies and public programs around the world in both rich countries and poor countries. And as such, it's of great interest to researchers, but it's been hard to establish this relationship really with solid answers, especially in poor countries. There's some work along these lines looking at effects of child investments on adult outcomes. The kind of famous INCAP studies from Guatemala, the Martorell's article there is one, and there's some evidence from rich countries, but really kind of limited evidence in low and middle income countries. And there's very good reasons why it's been challenging to establish this relationship. The first most obvious one is looking at, say, the relationship between child health and later outcomes is difficult because of omitted variables, confounding, endogeneity. So, children on average who are sick, sick children on average may be poorer or have different family backgrounds. So it becomes hard to say what's the effect of being sick rather than these other factors. There's also relatively few long-term panel data sets that are able to track children all the way into adulthood in low and middle income countries. I think people are familiar with the famous IFLS from Indonesia, and there's a few other very nice panels, but they're still relatively limited. And finally, even something as sort of central as the measurement of living standards in low-income economies, especially in agrarian, rural areas, is challenging, I think, as we all know, in development economics. So the combination of these factors has meant it's been hard to pin down this relationship. We're going to focus on the issue of worm infections, and then in particular in Kenya, where my co-authors and I have been working on this for a long time. Intestinal worm infections remain a major health problem around the world, with something like 1 in 5 people globally still infected. And they can have a range of negative health consequences, including anemia, stunting. They can lead children to be weak and tired. And the infection rates are particularly high today still in Africa and Asia, although there's some infections in Latin America and elsewhere. There's also some interest beyond the sort of direct nutritional consequences, which have been understood, I think, for quite a while. There's also potentially broader health consequences of worm infections that have become more obvious lately. So actually, worm infections can affect the immune system. There's some evidence that treating worm infections can allow people to fight off other infections like malaria. And worm infections may also affect the gut microbiome. And I think there's more and more evidence that the nature of the kind of bacteria and the whole microbiome can affect a lot of different health outcomes, cognitive outcomes. So those are other ways that worm infections could be influential. We're going to study a certain set of worms that are common in Western Kenya: hookworm, roundworm, whipworm, and schistosomiasis. These worms are transmitted because of bad hygiene and sanitation. So when people, defecate, the worm eggs are in the fecal matter. And so if people come into contact with the fecal matter, they can become infected themselves. Then the kind of worm eggs end up in your intestine, where they live for 1 to 2 years, 1 to 3 years on average, before the worms die off. So if you can actually reduce reinfection within a relatively short time frame, people's health will start to improve as the worms in their intestines start to die off. Okay, so the kind of policy environment is there's been a long-standing recommendation for almost 30 years to provide mass treatment for deworming in areas with at least about a 20% infection rate or prevalence. And the reason for this recommendation is that screening for the worms is rather expensive. You have to collect stool samples, so fecal samples, and analyze them in a lab. But the drugs are very cheap, costing much less than $1 per child per year when distributed at scale. They're safe, they have minimal side effects, they're quite effective. So mass testing and screening would just be an order of magnitude probably more expensive. There's been some debate about the attractiveness of those mass treatment programs. A well-known survey came out that found kind of mixed evidence or not much evidence of population gains for in mass treatment programs, although they find that when you treat infected kids, you find benefits. A more recent meta-analysis that I'm part of expanded the set of studies considered, brought in more data, and found actually significant effects on child health and nutrition of mass deworming programs. The other thing that's interesting about the early surveys, they actually include a number of studies in areas where prevalence was very low, single digits or 10%. Again, if there's almost no worms, you wouldn't expect to see much gain from deworming. If you only focus on the areas with at least 20% prevalence, like the WHO recommendation, then you get even stronger effects. So putting all the data together, there's quite a bit of evidence now that there are nutritional gains from mass treatment, but there's still limited evidence on the longer run effects of treating worms. And that's really where this study comes in. People may know of Hoyt Blakely's historical work on the US, which found that a big deworming program in the US 100 years ago did lead to education and income gains in the US South. But that's really, more or less the extent of the long run evidence. So what we're going to do here is actually report long run evidence, a 20-year follow-up based on the primary school deworming project in Kenya. This was one of the early RCTs in development economics. We started sort of setting up this project in 1997, Michael Kramer and I, and we've been sort of following this sample ever since. And this has been an influential study and was sort of acknowledged in the Kramer's Nobel announcement last year. The sample was 75 primary schools with about 30,000 primary school age children. And the deworming treatment was phased in over about 3 years with an experimental design. So the schools that were phased in earlier were chosen through the experiment, and then other schools were brought in later on. And I think some people on the call at least will be familiar with this design. The way it worked is, twice a year, drugs were sent to schools where teachers had received training, and there would be a mass treatment sort of morning where children would each take a pill, and that pill is quite effective at killing the worms in their intestines. And of course, not only could it benefit that child, but by killing the worms in their intestines, then those worms would no longer be passing worm eggs to the community through fecal matter. So this is just a photo from that first year in 1998, where kids are lining up and each getting a pill. The setting that we studied is an interesting one. It had quite high prevalence of infections at about 90% at baseline. So there are other settings with infection rates that high for sure, but this is a reasonably high infection rate. It's kind of nice analytically for us that there is such a high infection rate, because this is like we're estimating treatment effects on those who have infections. So, I think in that sense, it's useful. The drug costs are very cheap. The year that we started the project was also a year where there was extensive flooding in the area, which probably contributed to the high infection rates. And that flooding was associated with a big El Nino year. So people who know about El Nino know that 1997, 98 was a very strong El Nino. What ended up happening is the area was flooded. So the land behind that person there, that's me a long time ago. So I threw that in just for laughs. That's farmland that was flooded. And then on the other picture here, you see we had to get to a lot of the schools in early 1998 by canoe, by boat, because roads were flooded out. So, that probably contributed in part to the very high infection rates at the start of the project. Okay, so the design, as I mentioned, was experimental. The 75 schools in the sample were first stratified by geographic zone and then ordered by school population into a list from 1 to 75. And then we literally just counted down that list in the spreadsheet, 1, 2, 3, 1, 2, 3, 1, 2, 3, in order to divide them experimentally into 3 treatment groups. The group 1 schools started receiving deworming treatment and worm prevention education in 1998. Group 2 started receiving it, the next 25 schools in 99, and then group 3 a couple of years later. So there's a gap in the phase-in of 2 to 3 years. And typically in the analysis, as I'll discuss, we're going to put groups 1 and 2 together as treatment and group 3 as control. Although I'll talk about some nuances there later on. Another source of variation in the deworming treatment was a cost-sharing experiment that was introduced in 2001. The NGO we were working with wanted to see what would happen if they introduced some cost-sharing. They kind of believed in this model of cost-sharing with the community. So we convinced them to randomize the cost-sharing phase-in. So half of the group 1 and 2 schools in 2001, in those schools, parents had to pay a small fee to get deworming. In the other half, it was still free. And all of the group 3 schools still received the drugs for the first time in 2001 for free. So there's some variation in 2001 that we can also take advantage of. Effectively, what happened is when that small fee was introduced, the take-up rate fell a lot in the cost-sharing schools. So that's inducing even more variation in treatment status across these schools. So this is just a simple figure showing the study design. I think some people are familiar with it. The 75 schools were divided into groups. Group 1 received free deworming in 98, 99, 2000. Group 2 was phased in 99 and 2000. And then Group 3 was phased into treatment in 2001. So that's really the main variation, is this 2 to 3 years of additional treatment for children in the group 1 and 2 schools. And then there's this additional cost sharing element where some of the group 1 and 2 schools effectively had a lot less treatment in 2001. And again, I'm mainly going to focus on the core treatment term, but I'll show you a few results that use all the variation in treatment. Then in 2002 and 2003, all the schools received free deworming treatment again. So there was this kind of period afterwards where there was mass treatment in the whole area. And I'll come back later on to why that's kind of important. Okay, the second or the third sort of source of variation is exposure to local externalities. As I mentioned, epidemiologically, it makes sense that there would be benefits from treating people in your area because then they can't pass the infection on to others. In the initial analysis, we looked at variation in local treatment density within 6 kilometers of a school, and you can kind of see it illustrated here in this figure. Look at the group 2 school in the middle of the blue circle. You can see that by chance, because of the experiment and how it divided up schools between groups 1, 2, and 3, that group 2 school is sort of surrounded by mainly group 1 schools. So early on in the study, lots of schools around them were receiving deworming. That could have benefited their local disease environment. The other group 2 school near the red circle, close by, just happened to be surrounded by group 2 and 3 schools. So say in 1998, there would have been very little exposure to treatment nearby. So really what we're doing is sort of comparing schools like those 2 group 2 schools and seeing if infection rates are different because other schools in the vicinity were treated. What we find is some evidence of those gains out to 6 kilometers, but there was some discussion and debate about 4 or 5 years ago during a replication activity where there was actually an issue with coding around the externality effect. So what's really robust is that effect out to 4 kilometers. Basically, beyond 4 kilometers, estimates of spillover effects are quite imprecise. So it's really hard to know what the spillovers were at longer distances. But up to about 4 kilometers, there's strong evidence of external benefits from treatment. So the other thing that's interesting to keep in mind, even though we can't really detect statistically these effects at very long distances, it is possible that over time, the sort of spillover spread out across this study area. So I get treated, and that reduces your infection rate if you're near me. Your lower infection rate affects a school kind of close to you. So over time, these spillover effects could diffuse through the whole area. So there could be some sort of like baseline level of benefits in the whole study area. We show in some earlier work that would imply that our estimates are likely to be lower bounds when we just look at the treatment effect, because even the control group could be benefiting over time from these spillovers. But again, so you could think of our estimates in some ways as likely to be lower bounds. Okay, so what did we find in the earlier work? And I guess, again, some people are familiar with these earlier papers. Mass deworming led to schooling gains, some community health benefits. We found the drugs were effective. They greatly reduced the number of serious infections. There were some gains in self-reported health and height. And one of the core findings of the earlier work is that school attendance and participation increased in the treatment schools. So a pretty big reduction in school absenteeism. And there was this reduction in reinfection nearby, both among untreated children within the treated schools. Some kids were absent on the day of treatment, or their parents didn't consent to treatment. And then also within 4 kilometers, as I mentioned. So there's quite a bit of evidence of those spillovers. What we started shortly after that initial study was this long-run tracking activity. We took a random sample of students in the baseline sample, so about 7,500 students, and we've been tracking them ever since to try to understand if these gains in health, nutrition, and schooling translate into effects on things like living standards and adult life outcomes. One of the things that's unusual about the study is we've been able to track these individuals as they move. So if individuals over time leave the study area, they move throughout Kenya, they move to other parts of East Africa, we send our survey teams to collect data on them. Even some individuals that move outside the region have been surveyed by phone or by Skype. So this is an unusual aspect of the study. We've really benefited from generous funding in order to be able to do this. We've also benefited from the fact that cell phones have become so common in East Africa over the last couple decades. This has made it so much easier to track the sample over time. We feature, I won't get into too many details, people can ask if they have questions, but we feature a 2-phase tracking approach. In the first phase, we try to find everybody in the sample, and we usually get quite high rates of tracking, but then we're left with a subsample that's harder to track. Among that residual subsample that's hard to track, we then randomly pick a subset of them for what we call intensive tracking, where we'll literally spend like any amount of budget to send one enumerator all the way across East Africa to survey, that one individual. And then we sort of reweight that intensive sample to get the effective tracking rate. This is an approach that's been used in some other tracking studies. So the effective tracking rate over time is about 84%. Over the 20 years. So this is, quite a high tracking rate, not quite as high as IFLS, which is really like the gold standard, but still a very high tracking rate over 20 years. And even if you ignore this 2-phase design, another summary statistic is between the multiple follow-up rounds, we were able to directly find and survey 86% of the sample. So that's, that's really the core of this activity, is having those high tracking rates. Where do people move? They really move all over. The study districts in Western Kenya, Busia. 20 years later, about half the sample is still somewhere in Busia, but about half the sample has moved, many to Nairobi or Mombasa, these big cities, some to Uganda, some of them right across the border, some to Kampala, and others have moved even farther away, and we survey them by phone. In terms of the data collection since then, as I mentioned, we've carried out multiple survey rounds since then. There was the first survey round in 2003 and 2005. At this point, the sample were quite young, few were working, so we don't focus on labor market outcomes there. We really focus on the labor market outcomes in rounds 2, 3, and 4, which is really the 10, 15, and 20-year follow-ups. And as you can see in each of those rounds, the effective survey rate was around 84%. So really high tracking rates for each of those. And over time, the sample is getting older. So by the sample that we just collected, that I'm going to focus on quite a bit, the round 4 sample, most of them are kind of in their early 30s at this point. So they're really in their prime adult kind of labor market years. And that's really one of the neat things. We're tracking them from primary school to prime labor market years. And, we hope to continue tracking them, beyond that. One other aspect of the design I'll just very briefly mention is there was a random subset of individuals that took part in another RCT within this sample that provided either vocational training or grants to the sample. So those people who were randomly chosen for participation in those interventions are excluded from the sample in some of the later rounds. And then the control groups from those studies are reweighted in the data to maintain representativeness, although the reweighting doesn't make much of a difference. So I just wanted to mention that. If you actually include that vocational education and small grant sample in the full sample throughout, and just sort of put in controls on the right-hand side for those treatments, actually, if anything, the results tend to get stronger, but we exclude them because they kind of benefited from this treatment, and there may be some interaction between the later treatment and the deworming. But just to point that out, that there is a bit of a change in sample in the later rounds. Okay, so what do we know so far about it? I'm just going to summarize the Baird et al. Paper, which was published a few years ago. These are the 10-year results, and then I'll get to the 20-year results. So the thing that we found is after 10 years, when these individuals were, mainly in their early 20s, we were already seeing some evidence of labor market effects of deworming treatment. Among those who were earning wages, incomes were higher. There were also some effects on hours worked. And, the gains actually in some of these labor market dimensions in the 10-year follow-up tended to be concentrated mainly among males. So females tended to have smaller effects. They also tended to be concentrated among individuals who were somewhat older. So there are different cohorts in our data. Those in the older cohorts seem to have been gaining more in the 10-year follow-up. Now, in that Baird et al. Paper, what we write is, well, we kind of thought that the gains for those older individuals was driven because the younger individuals, those who were maybe 19 or 20 at the time, many of them were still in school or just transitioning into the labor market. So our hypothesis was, eventually as folks got older, both the older and younger cohorts in our data would gain. I'm going to come back to this because this is another relevant dimension for us in our data. So again, there were some gains for females, but larger gains for males. One limitation of that earlier study is we did not have very detailed consumption data. So we used a proxy for consumption, meals eaten. And we found that, this food consumption as proxied by meals eaten rose in the treatment group. Okay, so there were a range of different living standards gains. There were also health and education gains. So even 10 years later, self-reported health status was better in the treatment group. There were gains in total education completed by about a third of a year. In the treatment group, test scores improved. We administered some test scores 10 years later. Those had improved. What's interesting actually is a bunch of these education gains were concentrated among females, even though the labor market gains were concentrated among males. So again, I'm going to come back to that because we're going to find some related patterns in the 20-year follow-up. But for instance, among females in the treatment group, the increase in secondary schooling was really stark, a very large increase in secondary schooling. Let me just mention one other study very quickly, and then I'll get to the new results. Owen Osier has a really nice paper looking at the same experiment, but looking at a different population. He looks at kids who were very young, like infants or small children, when deworming was rolled out in the area. And he looks at those small children 10 years later, and he finds that those small children who did not get deworming drugs themselves, they were not in primary school yet, they could only have benefited from the externalities. He finds that the kids in areas where there was a lot of treatment, like in the treatment communities, do much better in terms of cognitive tests and some nutritional measures 10 years later. So that's another piece of strong evidence that the externalities are a story, and that there actually could be broader community benefits even beyond what we're measuring in the main sample. So I just wanted to put that out there. Okay, so let me get to this study and sort of what we do here. I don't know, Martina,
Ted,
yeah,
yes.
do you have a question? Yeah, go ahead.
Yeah, so before you move on to that, let me just raise one of the questions that has been asked, but I know you're going to cover that a little bit later. So you can say that you want to postpone that, is if you see different tracking rates by treatment arms.
Yeah, so let me get to that. We don't. So we're really fortunate that we have really good balance by treatment arms, and I'll show you a table showing that. So typically the differences are only 1 or 2%. They're not significant. And so that's been very useful for us. Yeah, thanks for that question.
And then one other question is if they're on the tracking rates, are they wave to wave, or are they relative to baseline?
Yeah, so they're relative to baseline, and that's really important, because if you only did it wave to wave, then over time, 0.8 times 0.8 times 0.8 starts getting small. So all of this is relative to the baseline sample. And so that's pretty important. So the tracking rates have actually stayed very steady over time. And you may say, how is that possible? I think as cell phones have expanded so much, it's really helped us. So that was one thing. And then the other thing is, in some of the early rounds, when people are adolescents or young adults, they're very mobile. But now that we're in like the 20-year follow-up, a lot more people are kind of like in the same place with a family, and they're not moving as much. So finding people between like round 3 and 4 was easier than between round 1 and 2. So that's how we've been able to maintain the rate. Those are great questions. Yep.
And a final one from one of the attendees as well. So are there any concerns about spatial autocorrelations of treatment and or outcomes?
Yeah, so we've definitely examined that in some of the earlier work, and sort of dealt with different ways of computing standard errors given that possible spatial autocorrelation, and haven't found that changes results. Of course, we're really interested in certain aspects of spatial variation to get at the spillovers, but when you look at things like Conley standard errors or other forms of spatial autocorrelation, it doesn't change the story. So again, thanks for that. That's a good question.
No more questions from the attendees for now.
All right, great. Okay, good. So I'll jump into the new stuff. So what's new here? What are we presenting beyond what I've already talked about or you may have seen? Again, we're looking at these long run effects on living standards and labor market outcomes. Again, what's noteworthy? A 20-year panel is very rare. This kind of respondent tracking rate that's balanced across treatment and control is unusual. So I think this is kind of at the core of the intellectual contribution, is the new data. This is just the table I was alluding to. If you look at just panel A or panel B here, and look at where it says surveyed among non-deceased. So those still alive, what rate are surveyed? You can see about 3% have died after 20 years, but the tracking rate is about 84%, slightly higher for females than males in that round, but no significant differences between treatment and control. If you look at the columns on the right, in the previous round, round 3, again, the surveyed among non-deceased was around 84%. In that round, it was a little higher among males than females, but no big differences. And then again, no treatment versus control differences. So again, maybe differences plus or minus a couple points, but overall, we've had this really balanced tracking, thankfully. Okay, so what else is noteworthy? In the latest rounds, we have complete consumption expenditure modules based on the LSMS. This is a big advantage. This is, the measurement tool that development economists think correlates most strongly with living standards. And through, again, generous funding, we were able to deploy this for the full sample in KLPS4. So we have, many thousands of these consumption expenditure surveys. We had run a kind of large pilot in KLPS3, where 1/6 of the sample also got the full LSMS consumption module. And so we're going to pool the data from KLPS3 and 4 here. Again, most of the results are driven by KLPS4 because there's just a much larger sample in KLPS4. We also expanded in our measurement of subsistence agricultural productivity in KLPS3 and 4. relative to the earlier round. So we're really kind of proud of the detailed measurement of economic activity. And then finally, for KLPS4, which is the first round of the data collected since the establishment of the AEA registry, we have a pre-analysis plan for what we do in KLPS4. So I'll kind of tell you what we said our primary outcomes were, what specification we would run. So that can be kind of helpful in also, establishing the credibility of the results. I'm going to very quickly go through the next couple slides because I think for a development. Go ahead, Martina.
Yes, yeah. One more question just. So a question on what is treatment and what is control. So initially you said there are 3 groups where 1 and 2 and 3 got it all in the end. So what is treatment and what is control among those groups that you described in the beginning?
Yeah, so we're mainly going to focus on group 1 and 2 together as treatment and 3 as control, because that's the big variation in treatment, either 2 or 3 more years of treatment. But in a couple slides, I'll show you the econometric specification, because we also look at the cost sharing variation. And then I'm also going to show you a figure and some results using like all the variation between group 1, 2, 3 cost sharing to give you a sense of what happens if you look at all the variation. So if someone's interested in that, I'll show it, but I'm mainly going to focus on group 1 and 2 versus group 3, which is what we did in some of the earlier papers. Thanks for that question. Okay, so measurement of living standards is very important. It's challenging with informal sector activity, subsistence agriculture, lack of wage data or tax returns, things like that. And that's really what the World Bank LSMS style household surveys were designed to address. And so, as I mentioned, in KLPS 3 and 4, we have these measures. It was a very long consumption expenditure module. It takes about an hour and a half to carry out. We had data on more than 150 distinct items that were either purchased, produced, that people received as a gift. So really the full LSMS, module. And I think people who run these surveys are familiar with this kind of design where, item by item across these 150 items, we ask about purchases, production, gifts in different units. We had to run detailed price surveys in many different regions of Kenya where our sample lives in order to convert units into value here. So, there really was an extensive activity to do this. And then the payoff is we get this detailed consumption data. We also have total earnings, which again, we asked about wage earnings, self-employed profits. We also got at agricultural value add. We tried to, ask a question about the value add in agriculture, including small scale home, agriculture. So again, it was pretty comprehensive. The one issue that we run into, as all development economists know, is a lot of agricultural activity. I think 70% is done in the family unit. So determining the individual agricultural productivity is quite challenging. So what we're going to do in terms of earnings is first I'll show you earnings where we add up all these things, wages, self-employed profits, plus any agricultural activity the respondent said was just their own activity. And that'll be one measure of earnings, individual earnings. But then I'm also going to show you a total household earnings measure that gets at value add in all household agriculture. And that can be beneficial because it captures more agricultural activity. Okay, so I'll show you both of those. This is the econometric specification. The outcome Y here is something like a consumption measure or earnings measure. And the main coefficient of interest is this indicator T for whether an individual was assigned to a group 1 or 2 school. So lambda 1 is the key estimate. And here we're going to condition on some of the covariates that were used in the randomization, the sampling. Of course, we'll cluster disturbance terms by school. Again, so we're going to focus on lambda 1. And as I mentioned before, in the presence of positive externalities like we've documented previously, it's straightforward to show that lambda 1 is a lower bound on the overall effect of the program because there are kind of benefits that may diffuse to the control group as well. The second source of variation, and then let me mention one other thing. In terms of heterogeneity, in the pre-analysis plan, we mentioned 2 dimensions of heterogeneity, gender and age, which we found were quite important in the earlier analysis. So I'll show you results broken down by gender and age. What we specified in the PAP were secondary tests were looking at the cost sharing indicator and then looking at the effect of local treatment saturation. So I'll come back to those. One thing just to highlight, because I may not have time to get into it, the coefficient estimate on cost sharing, as expected, almost always has the opposite sign to the main treatment. So that's what you'd expect. If you were a cost-sharing school, deworming treatment rates fell. That tends to have a negative effect relative to, say, positive treatment effects overall. So I'll come back to it a little bit quickly, but the kind of pattern of effects is what we expected. Okay, so what do we find? Let me summarize the main results, and then we'll get into some of the details. We find that there are gains in various consumption measures, earnings measures, wealth measures, so various economic outcomes in the range of about 7 to 14% in the treatment group, group 1 and group 2, versus the control group. The average consumption gain was about $300 per year in purchasing power parity adjusted dollars. Hourly earnings were up about 13%. This is just the summary, and then I'll give you guys the details. And again, as we found at 10 years, we find that at the 20-year follow-up, we're finding evidence for larger gains for males and still larger gains for the individuals who are older, who are in the older cohorts. And that's an interesting finding, as I'll come back to, because basically everybody is out of school at this point. The younger cohorts are like in their late 20s or maybe 30, 31. The older cohorts are in their early to mid 30s. And we're still seeing this difference. So I'll have a slide in a few slides trying to understand that. Another interesting result is we do see a shift in sector. There's a shift out of agricultural labor into non-agricultural labor. So there really is a shift in the nature of employment in the treatment group, and closely related to that, we see an increase in migration to urban areas, including a lot of people who moved to Nairobi, which is, a big city, very different than rural Kenya. So in many ways, the deworming treatment group's lives were transformed in some way if they moved from the village to Nairobi. And then finally, at the end, I'll get back to the kind of rate of return calculation. You could already imagine what I'm going to say there, which is since deworming costs less than $1 per year to treat, and we're seeing very large gains in earnings and consumption, the rate of return is very high as a public policy. Okay, so what are some of the results? This is one of our main tables. And let me just start with consumption, which was one of our two main primary outcomes. The other are the earnings measure. If you look at the full sample here, you see this gain of about $300 in consumption. Again, this is the pre-specified regression specification. The treatment effect there is about 14%. I'm not showing it here, but if you break it down into food and non-food, you see positive point estimates for both. So it looks like there was kind of a gain in both dimensions. If you then turn to columns 2 and 3, you see most of this gain is really concentrated among males. There's a positive point estimate for females, but it's much larger for males. So that's really a striking result. Another interesting pattern that we're really curious about, we want to investigate more, is even the difference there's a difference in the control mean in consumption between the females and the males. So, possibly due to effects of this individual's own productivity, possibly due to differences in marriage patterns or fertility patterns over time, it really looks like the males are living in somewhat better off households that have higher living standards 20 years later. So I think this is really worth exploring. We don't have a perfect answer yet. We were actually halfway through a survey when COVID hit, another module of this round to really get detailed information on fertility, marriage patterns, child outcomes, et cetera. So once the COVID crisis is done, we want to go back in the field to get that data, because that may shed light on some of these gender differences here. Columns 4 and 5 break the data into the older and younger cohorts, so above median age at baseline and below median age. And again, you can see all the effects are concentrated among the older cohorts. For the younger ones, it's basically a zero effect. So I'm going to come back to that in a couple slides. That's a really interesting pattern for us. Okay, so this is just presenting the raw data, pooling all the sample, consumption expenditures per capita. The black line is the distribution in the treatment group, the gray line in the control group. And you can kind of see a shift to the right, in the right tail, in the left tail. There's kind of a shift in this distribution. And that's really what's driving these consumption gains. When we look at the data round by round for consumption, here in terms of this figure, we break it down into males and females, and then we have all. So you can see those 3 different ones. We also have the data by round. So we only collected the consumption data in KLPS 3 and 4. As I mentioned, in KLPS 3, we only collected it for 1/6 of the sample. So you can see these huge confidence intervals for KLPS 3, much tighter confidence intervals in KLPS 4. And it's really the KLPS4 results that are driving the overall results. So, this is sort of just, again, the raw data that goes into that main $305, number. Again, larger gains among males than females consistently. Okay, what about this heterogeneity? So this is a really interesting part of the paper for us. And again, these two main dimensions are gender and age in terms of heterogeneity. And we did a lot of work earlier this year trying to explore what was causing these differences. So we looked at things like, well, when we go back to the baseline data, was it the case that females and males had very different baseline infection levels? Because that might drive differences in treatment effects. We didn't find that. Did we find that there were big differences between males and female students between their family socioeconomic backgrounds? We didn't find that. So it didn't feel like that could explain the results. What really does seem like it's important is there are very big differences in labor market opportunities for males and females in this setting for basically pretty poor families in rural Kenya. When we look at the type of work that males and females do, they're very different. They're very segmented. The types of occupations they're in are very different. Once you get outside of agriculture, obviously a lot are working in agriculture, but outside of agriculture, they're quite segmented. And we also have very detailed data on KLPS4 about home production. There are huge differences in the amount of time females and males are spending on housework, domestic chores, childcare, multiples. Women are spending 2, 3, 4 times more hours per week on all those activities. And those are activities that are a little harder for us to measure in terms of women's productivity in those activities. So we could be missing a lot of productivity for women in some home production. One of the things that we're doing right now, again, we're in the field, although we were disrupted by COVID, is we're also estimating effects on the children of our sample. So to the extent that some of these human capital gains and other gains in the treatment group come through in better childcare, better home production, et cetera, we may actually see benefits or effects on the children of our participants. So that's something we're really keen to explore in future work. So we don't have a definitive answer on the gender difference, other than to say there clearly is a lot of, there's a lot of constraints that women face in the Kenyan economy and society for sure. And there may be dimensions of benefits we have not yet measured. So that's our kind of take on some of the gender differences. The age differences are another matter. And again, very interesting. Again, there are larger gains for these older cohorts, those who are in their mid-30s. It's not due to school enrollment differences anymore. Basically, by the 20-year follow-up, almost nobody is in school anymore, only 3% of the sample. There were no differences in baseline infection either for slightly older or younger kids. So that doesn't seem to be the case. Initially, we thought, well, maybe it's just like a life cycle effect. So maybe as the younger cohort kind of gets into their mid to late 20s, they'll start gaining more. But now in the 20-year follow-up, the younger cohorts are in their mid to late 20s and they're still not seeing gains. Whereas the older cohorts, 10 years ago, were seeing gains. So, that doesn't seem like a good explanation either. There were a few notable differences, though, for the older cohorts. The first notable difference is if we look at the gain in schooling, school enrollment, years completed over time, those older cohorts showed much bigger gains than the younger cohorts. The average gain in the older cohorts was closer to half a year of schooling, which is a pretty sizable gain in the treatment group relative to the control group. You may say, well, why would that be the case? One possibility is during this time period, there was a big increase in overall enrollment in school, going to secondary school in Kenya. So the younger cohorts in general, like in the control group, have way more schooling than the older cohorts. Literally within that 5 or 6 year span, there was a big increase in average levels of education. So it feels like those cohorts that were already getting much more education, the deworming didn't do as much to boost further schooling for them. Whereas in these older cohorts that were getting less education, it had more of an effect. So that's one possibility. Another interesting thing that we found in the data has to do with social networks. Remember, again, the treatment is assigned at the school level. It turns out that there's significantly more people in the treatment group who claim that they found a job through their schoolmates, literally from their primary school. We asked specifically about their primary school, and those effects are concentrated among the older cohorts. So there was something about the social networks in the older cohorts that could have helped them. Okay, the last thing I want to talk about, which is kind of an interesting epidemiological finding, is it may have to do to the levels of deworming. So This is how it works. Remember, as I told you, there was this phase in of deworming between 98, 99, 2000, and 2001. But then in 2002 and 2003, all the schools received mass deworming. What happens effectively in our sample is in those older cohorts, many of them in the control group actually dropped out, left school, graduated from school before their school ever got phased into deworming. So in the older cohorts, in the treatment group, on average, people got 2 or 3 years of deworming, let's say. In the control group, very often they got none. So in the older cohorts, we're comparing like 0 to 3 years of deworming, let's say. In the younger cohorts, because deworming was eventually phased in, it's like we're comparing getting 2 years of deworming to 5 years of deworming. So to the extent that every additional year of deworming has a smaller marginal effect and there's some concavity, that could help explain these results. In the older cohorts, it's like comparing 0 to 3. In the younger cohorts, it's like comparing 2 to 5. So this next figure kind of shows this graphically. The two panels on the bottom show the distribution of years of assigned treatment using all the variation. This is what I was telling you about before. Group 1 versus group 2, cost sharing, not cost sharing, all the variation in assignment to free deworming. And you can see for those older than 12 at baseline, the median, the typical kid got 0 deworming. If you look at that light gray bar all the way on the left, the typical kid in the treatment group got 3 years of deworming. So big difference. The bottom panel are the younger kids, and the difference is more like 2 to 5 or 2.5 to 4.5. The top panel then uses all this variation in assigned deworming. There's a couple patterns worth noting. This is for consumption. The first thing to note is this is reassuringly monotonic, meaning every additional year of assigned deworming, you tend to see higher and higher treatment effects in consumption when we use all the variation. But what you can see is at these very high levels of deworming, from like 3 to 4 years to 5 to 6, you start seeing some concavity. There's sort of less of a gain between 3 and 4 relative to, say, when you go 1 to 2 to 3 to 4. That's a steeper slope. So this is a bit speculative. We've tried to look through the epidemiological literature if people have done this kind of dose response to get at concavity, convexity. We haven't found evidence for it. So it's speculative, but it could tell part of the story. Okay, so I can come back to that during the question, part if there's some issues there. Let me in the last.
So Ted, let me.
Yeah,
there's one question on consumption from the audience. So the effect on this consumption would be easier to interpret if there was no difference in household size and composition between treatment and control. Is this the case here?
Yes, there's no significant difference in household size. I should have mentioned that. We looked at that. And there's no significant difference in number of adults and children. But again, we're going to be exploring in detail the details of that when we get the further data on marriage patterns and whatnot. But at least the first pass household size, no significant difference. We were interested in that as well. And then, thanks for that question.
And then one comment on this bigger impact in the older cohort from the audience as well. So the overall treatment effect, as you've shown, is bigger for the older cohorts, but the control mean of the younger cohort is larger than that of the older. And is there a way to explain that?
Yeah, exactly. That's a really interesting pattern. And again, our best explanation, or the most likely explanation, is in that younger cohort, completed years of schooling and these other human capital measures just look way better in the control group if you compare the younger versus older. So this was just a period of like really big schooling expansion in Kenya, universal primary education, big expansion of secondary school enrollment. And those younger cohorts in general are just doing way better than the older cohorts. So that's our best take for the difference in the means there as well.
Thank you.
Thanks for that question. Okay, so let me tell you about some other effects. Here we have two different measures of earnings. And again, earnings is our second primary outcome. We have in panel B, individual earnings. So individual wages, self-employment, and individual agriculture. And then the bottom panel is total household earnings for the respondent and other adults in the household, typically 1 or 2 other adults, plus all the joint agricultural activity, which again, for many of our households is a very important share of their income and production. What you can see in the top panel is in terms of earnings, there's a gain of about $80 per year in current purchasing power parity dollars, treatment effect about 6.5%. Again, if we compare females and males, the gains tend to be concentrated among males. although these are relatively imprecisely estimated. And again, gains among older and not younger. So it's that same pattern. Males and older tend to be seeing larger gains. None of these are significant other than the older at traditional confidence levels. In panel C, we look at total household earnings, again, which brings in this kind of joint agricultural activity. Here, the gains are somewhat larger. It's kind of nice here. If you look at column 1, the total gain is $239 here. It's a pretty large percentage effect. The gains in terms of consumption and household earnings actually are quite similar. So if we just look at KLPS4, we only collected household earnings, total household earnings in KLPS4. We look at total household earnings, including agricultural production and everything, and we look at total consumption. The treatment effects are pretty similar, $239 versus $199. So that's kind of reassuring. We're trying to measure both sides of the ledger. Again, the total household earning gains are concentrated among males rather than females, and among the older sample rather than the younger cohort. So it's kind of the same pattern over and over again, with quite sizable effects in terms of percentage gains. Okay, how about other outcomes? Here we break down the economic outcomes into some subcategories. We look at annual log earnings among only those who have positive individual earnings. Here there's about a 9 log point effect. And then if we break things down into like wage earnings, self-employed profits, individual farming, we see some evidence of gains both for wage earnings and self-employed profits. For farming profits, not so much, but if you look at the mean, again, it's very low because what we can identify as the individual is the only person who worked on that farming activity is very narrow. Most farming activity is a joint household activity. There's also some evidence of non-zero earnings gains by about an increase by about 2 percentage points. Hourly earnings go up by about 13%. So again, gains in a variety of different measures. We also in KLPS4 tried to collect quite a detailed measure of household wealth, durable assets, other assets, financial wealth, and we add them together and we get a positive point estimate of about a 13% gain. So a lot of the estimates are kind of in that range of 6 or 7% up to 13 or 14%. So, if I had to give you one number on like what was the gain in terms of, economic well-being or earnings or what, that's around 10% across all these different measures. And here's a final set of results, and then I'll get to the cost benefit. Here we look at sector and labor supply. Again, we see this big increase in urban residents in the full sample by about 4 percentage points on a base of 45%. So almost half the sample is living in a city at some point during these later rounds, and it increases by 4% with gains somewhat higher among males. Total hours worked increase on average by only about one hour per week, although again, larger for males and older by about 2 hours. But what's interesting here is that hides some heterogeneity. Hours worked in agriculture is falling by about an hour. Hours worked in non-agriculture is increasing by about 2 hours. So, total labor supply only goes up maybe a little bit, but there's this big shift in activity. Again, the shift into non-agriculture could be linked to the shift to urban residents with different types of jobs. What we also do is look at employment in different types of occupational categories, the primary sector, services, construction, manufacturing. In the 10-year follow-up, we found some interesting results here. We found a big increase in that case in manufacturing employment in the 10-year follow-up. And that was something that we were pretty interested in, really felt like a real change in the nature of employment. That doesn't come through in the pooled data. The point estimates are very close to zero. So we're not sure exactly why that effect sort of disappeared or went away, if it has something to do with maybe a lot of those manufacturing jobs being concentrated among quite young workers in their late teens and early 20s. So in the 10-year follow-up, we see it. But if people get burned out of those pretty intense jobs by their mid-20s into their 30s, then we don't just see much manufacturing at all. In fact, the control mean on manufacturing is only about 2%. So very few people are actually doing manufacturing work here. Okay. So let me talk about additional sources of variation very briefly. I alluded to this. As I mentioned, the cost sharing measure almost always has the opposite sign of the main treatment measure. I'm not going to get into the details. The magnitudes are smaller than the main treatment measure, as you'd expect, but opposite in sign. Whereas in terms of spillover effects, it's more of a coin flip. There isn't really much of a relationship between the main coefficient estimate and the sort of spillover effect. It feels like a zero, but a lot of the point estimates are quite imprecisely estimated when we get out to the 20-year follow-up. So it doesn't feel like we have a lot of power to detect the spillover effects at this long time frame. And again, if spillover effects diffuse over time, it may get harder and harder to detect those initial spillovers. Okay, so I can get to the cost benefit, unless, Martina, should I just go straight through, or do you have any questions at this time?
So there are lots of questions, but I think we leave them for the Q&A, and you have your last couple of minutes to finish up.
Sounds great. Okay, let me just take the last 2 or 3 minutes. That's good time. So as I mentioned before, the cost of deworming, the actual drugs and the delivery, is very low, only less than 50 cents per kid per year. We're also going to consider another cost, which is, given the short run increases in school participation and attendance, to maintain class sizes, there might need to be additional teacher costs. So we actually are factoring those potential costs in as well. Now, in the real experiment that we study, there was no indication in any of our data that the Ministry of Education was deploying extra teachers to the treatment schools. But this is just thinking about kind of a broader cost benefit. So we're going to factor in those costs, even though they probably weren't relevant in our case. We're going to focus on the benefits of higher earnings and higher consumption in the treatment group. In many ways, this is a lower bound because we're not going to look at the direct health benefits of improving child health. And there's a whole industry of people measuring disability adjusted life years and other things to try to quantify those child health gains. We're going to leave those aside. We're going to leave aside spillover effects like the Owen-Osier effects or our earlier spillover effects, and just look at treatment group earnings and consumption effects. And in some cases, we'll also get a back of the envelope as to how much revenue the Kenyan government could get from any of these, say, earnings gains. So what do we find? Let me not go to the cost benefit equation. I think for economists here, we're all familiar with discounted costs and benefits, but again, we have the deworming cost, the teacher cost, and then the benefits in terms of earnings. And we assemble relevant data for Kenya, which you can read in the paper. But I think that this timeline will show it more clearly. And then I'll wrap up. In the early years, there were initial deworming costs. You can see that very small line there because they're tiny, the deworming costs. And then there's some teacher costs over this first 9 or 10 years if there's higher school enrollment rates. What we're able to compute is what type of gain in earnings or consumption we would need in order to have like a decent social internal rate of return. So the earnings gains we would need to have an annual return of 10%. And that's roughly the sort of return, the real return on Kenyan debt over this period, Kenyan government debt. That return would be a gain in earnings per year of about $8, just to give you a sense. What do we actually find? We find average earnings gains more like $80 in what I just showed you, and we have these average consumption gains of like $300. So the bottom line, when you look at the net present value of deworming, it's huge. The net present value is hundreds of dollars per child dewormed. The social internal rate of return per year annualized is 36 or 40%. So just like a huge rate of return. And it even turns out that the amount of tax revenue the government could collect is almost certainly higher than the initial costs of the program. So this feels like a very high return on activity, partially because the costs are just so low to deworming, although we're also factoring in the teacher costs. Okay. So this is my last slide, and I really look forward to the questions. So just final points. I've gone through this. We find that this child health investment in Kenya, when we track people over many, many years, appears to have delivered improved adult living standards and labor market outcomes. What are some of the implications? There's a lot of debate about when health and nutrition programs should be targeted, at what age. And, there's a point of view that really only the youngest kids will benefit, but our results really go against that. We're finding that primary school age kids are still benefiting from a school health intervention. And it's worth noting that some of the recent evidence from the US, like this kind of brand new QJE paper by Hendren and Sprung-Kaiser, finds something very similar in US health and nutrition programs. Even those programs targeted at primary school age kids show very high rates of return. In terms of external validity, one thing to keep in mind is Busia really did have a very high rate of infection at baseline because of El Nino, because of just general infection rates. So this is a setting where almost everybody's infected. Not every real world setting has such a high infection rate. So in other settings with lower prevalence, you might want to scale down the benefits that we show here. That would be reasonable. At the same time, analytically, this is very useful because basically we're studying studies infected. So we're seeing the treatment effect on infected people. And finally, as I alluded to, we're still tracking the sample, the main sample. We're collecting data on their children. We're very interested to see if improving their parents' lives when they were children has any sort of effect on children, positive, negative. We're gonna measure it as carefully as we can. And we're really interested in whether that may differ by gender. If something about the benefits for, say, female recipients of deworming get revealed through family outcomes rather than market outcomes alone. Okay, so let me just leave it there, and then I'm really excited about the Q&A.
Thank you so much, Ted. An impressive study and a very timely presentation. So just one small thing before we move on to the Q&A is that if you want to talk to Ted about his research paper after this seminar, please email the VDEV email, and you find it in the chat room. You can see the email there, and then you will get a link to his Zoom room. Okay, so now we open up the floor for people to ask the questions to Ted. So who wants to get started? So while we wait for someone to raise their hands, I'm gonna bring up one question. So Amy Chin asked the question, I remember take-up was lower for older girls in the original intervention. Also, when you think about the dosage per years of exposure for girls in the treatment group versus control group, is there less difference than for males?
Great. Should I accumulate questions, or do you want me to go one by one, Martina?
So as you want. Now there's lots of hands raising. So what do you prefer?
Oh, okay. Yeah, I can go one by one. I think that's fine. So thanks, Amy, for that. That's definitely right that in the initial study, there was girls older than age 13 and older were largely excluded from treatment due to concerns about potential risk in case they were pregnant. And that's a concern that the WHO kind of, even 1 or 2 years later, kind of eliminated. So in mass treatment programs today, those concerns are not relevant, but at the time, it was a policy issue. So that is a potential, reason for gender differences for sure. But one of the things that we did investigate is the treatment effects on infection rates from the program. And there are still large reductions in infection rates for females, partially because a lot of the younger females were getting treated, partially because there was imperfect compliance in the field with the exclusion of the older girls. So some of the public health nurses at the time didn't like the WHO recommendation, and then some subset of the girls got treated anyway, and partially because of the within school spillovers. So even the untreated were showing these big reductions in infection rates as the disease environment improved. So there isn't like a striking difference in reduced infections across males and females that we feel could explain these really big labor market differences. But thank you for that question. That's something that we explored in the data.
I'm opening up the mic for Anna Tomstedt to ask her question.
Hi, thanks for an awesome talk and
Hi.
very interesting project. So I was wondering, does it matter? Do we know much about how much it matters who in the household you ask about consumption expenditures? Like, does it systematically vary whether you ask a man or woman? I guess me and my husband would probably give you different answers to our consumption expenditures if you asked us. And I just wondered if that would help figure out some of the differences.
I think it's a fantastic question. It's something that we've debated and grappled with, and sort of on the agenda for us going forward is to run, of course, consumption surveys are quite time consuming, but run some medium, moderate number of consumption surveys, interviewing males and females to see if that can explain some of the differences. Because I think you're right that in explaining those differences between average consumption between males and females, there's several possible explanations, but one could just be measurement, right? Just reporting. So I think that's a great question. Thanks for it. And I do think that this average difference in consumption between males and females is one of the kind of cool, interesting things that's come out of the data that we want to explore in the future. So thanks for that. Yep.
Thanks, Ted.
And next question is from David Bernard. I now unmuted you.
Hi, Ted. Thanks for the talk again. So yeah, I was just wondering if you had any evidence on whether deworming crowded in sort of more parental investment, because that seems like that should go in sort of the cost side of the cost-benefit analysis as well.
Yeah, thanks for that. That's really what we're in the field trying to, you're saying, not among the children of our participants, but like the original sample. Sorry, I'm already thinking ahead to the intergenerational stuff. Yeah, so we are definitely measuring right now in the field about like whether the guys who got folks who got deworming themselves are treating their own children differently. In terms of the initial participants, the initial sample, we have some data related to that in the initial surveys, but not a ton, and not the kinds of like really detailed measures that we would like. We do have some things around access to healthcare, whether kids were, brought to clinics more, or there were some, differences in those issues. Of course, the health ones in particular are hard to interpret as parental investments alone, because the treatment could have affected health. So that's where we run into some of the limitations. We do have some data on things like whether parents had bought shoes for their children, because we recorded whether children were wearing shoes. For instance, because wearing shoes can help prevent certain infections like hookworm. We don't see significant differences there. So we have like incidental evidence on certain dimensions of parental investments, and don't really see evidence there. But it isn't the kind of really detailed data that we would like, or that we're collecting today for the intergenerational analysis. So I would say that's the limitation of some of the early data. Thanks for that question.
And next person to ask the question is James Allen, and you are unmuted. James, you are now, it's possible to ask your question. You might have to unmute yourself on the screen, maybe.
Yeah, I can't hear.
Me neither.
How about now? I apologize. Can you hear me now?
Perfect.
My apologies.
Yeah, great. Thank you.
Sorry about that. James Allen, University of Michigan. Thanks for the great talk. You were talking about Hoyt Blakely's deworming paper earlier.
Yeah.
That got me thinking about Hoyt's talk about how we're making this health investment, and that's the health investment itself is going to have a direct impact on future income just simply by improving the health of the individual. But that also makes education a better investment for that individual. And so we look at this return on investment, and I think the question that comes to mind is this because of improved health or because of improved education? Have you guys been able to kind of explore that question? I think very simply just including schooling as a control with the treatment regression and seeing where the variation goes. Do you have any thoughts on that?
Thanks a lot. I really I know the paper you're talking about for Hoyt, the kind of follow-up to his QJ paper, that annual review piece where he tries to kind of get at this, what dimension are you investing? I really like that paper. So for us, I do think that there could be direct health effects in the labor market, and it could work through education, and that choice becomes really critical. There is some work related to Hoyt's paper by Rosenzweig, Pitt, and Hassan in the AR, I think 2012, which makes kind of a related point to Hoyt, which says like individuals with different sort of proclivity for, schooling or the labor market could make very different choices when there's a health investment, and it could kind of go either way. And the Rosenzweig et al. Or Pitt, Rosenzweig, Hassan paper makes the point that could explain some gender differences. So if you're in an economy where, there's segmentation in the labor market, there's very different skills that males and females are able to use in the labor market, you could see a very different human capital versus labor market response for males and females. So it relates a little bit to your point. In terms of this issue of mediation, you're kind of saying like, what are the mediators? Can we put some of these intermediate outcomes on the right-hand side? We've really hesitated from doing that just because we see that education was directly affected by the treatment. So we could be in a kind of, bad control type situation, as Angrist and Pischke, would put it, or others have put it. So we've stayed away from that. Plus we kind of see the investment in health and education and labor market outcomes and your social network and all these things kind of interact in really complex ways that could be very hard for us to fully pin down. So we've hesitated from really saying, okay, this percent of the effect is due to health, this percent is due to education, this percent is due to social networks. And what we've really done here is a little bit more, give you the kind of full constellation of results without being able to pin it down. So I think that's a limitation when you have like one instrument. We have like the one treatment, and it could affect lots of stuff. We feel like we're just not identified to identify all the channels. So thanks for that question. It's one we certainly get a lot and we've thought about a lot, but we've opted for a bit more of a reduced form approach at this point.
Okay, thank you very much.
Thanks.
And then we have a question from Mayor Brooks, and I now have opened up for you to talk.
Yeah, hi. Thank you very, very much for the talk. I wanted to ask regarding the rate of return. So given that the rate of return and the returns seem so high, even conceptually on an individual or very local level, the inevitable economics question is, so why isn't this done already? And why isn't this done without any kind of intervention?
Yeah, it's a great question. Michael Kramer and I wrote a paper a long time ago, 2007, called The Illusion of Sustainability. That was kind of all about that, in the context of deworming. But I think there's a couple, let me give like two main responses. One is like a lot of this is going on. So since our research happened and other scholars working on deworming and have sort of studied its effects, now hundreds, millions more kids a year are receiving deworming. There's mass national deworming in Kenya now. There's mass deworming in India. Nigeria is expanding. So on some level, like it is happening. And so that's that. Those are big public programs. In terms of the kind of private versus social benefits issue, it's a great point. And this is where, in our view, epidemiology is quite important. So, when individuals get treated, they benefit, but they also create this external benefit for the rest of the community. And those benefits could be quite large. So, even individuals that don't get treated themselves, if they're living in a community where like all the other kids got treated, their worm loads are way, way lower than they would have been otherwise. And that's because the worms only live in your intestines for like a year or two. They start dying off. So if you're in a community where you're not getting reinfected for a year or two, it's like most of the worms can die off. So our best explanation of that is there really is this wedge between the social benefits and the private benefits that, would dampen private demand. So it does make sense to us that there would be this public response in terms of these big public health programs that are expanding around the globe, as we've seen. So thanks for that question. It's really like some of the cool economics around the economics of epidemiology relates exactly that issue.
Thank you very much.
Okay, so that was the last question from the audience. So a great set of questions and very active audience during the presentation as well. So Ted, I'm going to take the opportunity to ask one question that I think all of us are thinking about. And that question is, for how long are you going to follow these people?
Well, this has been something I've been working on for a long time. And now there's, Michael Walker's here and the broader team. We've all been working on it now for a while. I think we want to keep going. It's at this point, my feeling is the benefits of the panel alone intellectually are very large, even, independent of the experiment. We're actually now with co-authors, we're writing several papers, just taking advantage of, looking at migration patterns, the panel. So I think we want to keep it going. And, for me, like I went to Busia the first year after my first year of grad school. So for me, like this study is part of what I do. I almost can't imagine being a researcher and not working on this study. So, maybe when I retire, I'll stop and maybe I'll hand it over to Michael or somebody else who's on the call to keep it going. So that's our plan.
So that sounds great. We look forward to hearing about those. And I'm also very curious to actually learn about the data that you're waiting to collect now after COVID on, the family situations, their kids, what is the health status of their kids? Are they giving them deworming drugs and so on? So that's going to be an interesting follow-up as well. Thank you so much, Ted. It's been an amazing talk, full of energy and very interesting. Next talk is on October 13 with Ben Olken, so 2 weeks from today. And remember that if you want to talk to Ted about something related to this paper, send an email to the VDEV email that you see in the chat, and you're going to get the link, and Ted will be there with those who wants to chat for the next minutes. And you will log in there very soon, right, Ted?
Yeah, in 5 minutes. Once we're done here, I'll just I'll log in. Yeah.
Yeah. So thank you everyone for participating, and see you in 2 weeks' time. Thank you again, Ted.
Thanks, guys. That was really great.
Bye-bye.
Thanks, everybody. Good to see you guys.